Okay, assalamu alaikum and hello everyone. Our subject is digital signal processing or DSP. We have three types of signals: analog signal, digital signal, and discrete signal. Sometimes the discrete signal is considered as a digital signal. Even in some books, they don't write or they don't say digital signal processing. They write it as discrete signal processing. It's same like digital signal processing. Uh, Actually, in reality, there is no digital signal and not even discrete signal. The natural signal is analog signal, like sounds, pictures, videos, etc. So, for example, the human voice generates a signal that is actually analog signal. But we can convert the analog signal to digital signal through three phases. First, sampling, then quantization, then coding. So to convert it from analog to digital, we need it will be through three phases: sampling, quantization, and coding. So first, sample the signal, then quantify it to determine the resolution of the signal, and finally set binary values and send it to the system to read the digital signal. So once you cut the analog signal, once you do the sampling, it will convert to a discrete. But once you complete the other two phases, quantization, then coding, it will be converted to digital signal. Okay, now let's differentiate between analog and digital and discrete signals to understand why we always use the digital or why we consider it as the best signal to deal with. So as you see here we have a sine wave, here we have cosine wave, and here a noun shift. So in sine wave, the value, we have value in positive part and in negative part. Here also in positive part and in negative part. Here in the unknown shape, all the value is in positive part only. So of course, any signal consists of amplitude. This is the main important factor in analog and digital and all type of signals. So the difference between analog and digital, or the most important difference between them, is the analog. In analog, the amplitude is always continuous and change with the time, as you see here. In analog, the amplitude is continuous and change with time. That means the amplitude keep changing as time also changing. What does it mean? What does amplitude mean? The amplitude is the amount of energy that we need to carry or to move a signal from one place to another place. So more distance that we need more energy to move that signal. For simple example is loudspeaker. So our voice normally reaches maximum to 50 meters. But if we talk through loudspeaker, the loudspeaker will help us to amplify our voice. Actually, it will amplify the amplitude of our voice. So same things for the signal. Amplify the amplitude of signals to allow it to move to further distance. In analog, the amplitude is continuous and change with time. So here we got value of amplitude. Here we got different value. Here we got maximum. Then it will going down. then it will go into negative part, then going up. Here, for example, an unknown shape, also the amplitude keep changing here. Value, here we got value, here we got the maximum value of amplitude, and so on. So the main problem with the analog signal is that the power of the amplitude is not constant, not fixed. Sometimes going up, sometimes going down. Therefore, it doesn't serve us to do calculation in electrical or in sensitive devices. It doesn't serve us when the signal keep changing, means the amplitude going up or going down. Okay, so if we take a look to digital signal example, see how it looks. The signal also continues with time, but the difference here is that the amplitude is constant from 0 to 1. For example, okay, we have same amplitude. For example, here in the positive part, let's say 5 volt. This is 5 volt. This is minus 5 volt. So we have constant amplitude, plus 5 or minus 5. So not like analog. The amplitude not keep changing with time, going up and going down. The signal is stable, plus 5 or minus 5. There is no 4, there is no 3, there is no 2. So the amplitude is constant. And this is very important that we can take advantage of this type of signal in sensitive devices such as computers, satellite, and cameras when we do calculation. So the main difference between analog and digital signal that the amplitude in analog signal is changing with time, while in digital, the amplitude is constant. What about discrete? Take a look to a discrete here. Actually, it's same digital, but we cut it. We discrete it. The difference here in digital, the signal is continuous with time, but in discrete, okay, if you notice here, we have same time. We have same time. The amplitude here also constant, here also constant, plus 5 or minus 5. So for example, from this point to this point, okay, starting from 0 until 5 milliseconds, for example. And in discrete also, same time. Here also 5 milliseconds. Okay. Here, the 5 in digital, the 5 millisecond, the 5 second is continuous from 0 until 5. So the signal is continuous. But here in discrete, we divide the 5 millisecond. We divide it into 6 sections. We divide 5 by 6, we got 0.8. So from here to here, 0.8. From here to here, 0.8. And in total, we got 5 seconds. That's why we can take more advantage of this type compared with digital signal. That's because instead of time being continuous, like in digital, it will be discrete. Okay, as I mentioned before, any signal in reality is analog signal, mean continuous signal. To dealing with this signal, need to convert it to discrete. A discrete signal is a time series consisting of a sequence of quantities. In simple word, you can say we just cut the sine wave for certain t. For example, we have this sine wave example. It will be like that. Yeah. This signal will have constantly different value over the time. Okay, here we have value in positive part, and here we have a value in negative part. And each second we got different value. That's why to dealing with it need to convert to discrete. So the discrete will create a system that enables us to take sampling. Take sampling, right? And each fixed period, it will take a sample of this signal. Yeah. Each sample, we can call it this T1, T2, 3, and so on. And each sample got a value. For example, this got 1 amplitude. This is 1.5, depend on the given amplitude here. So now we understand how to deal with analog signal. Okay, so when we cut this sine wave, in result we will have this. Okay, this is like intermittent signals like this. We can study them in BS. So this number of intermittent signals, we call it sampling. Call it sampling. And we samplize it by n. Okay, so here the values of n will define the system, or will define this system for us. Yeah, the value what we can get from this figure, we can put it in array like this. X of n. Okay, this is just for example that we get this value from that figure. 4 and 7. Series. So now we want to address this value. To address this value, to give an address to each value like this. How we do that? First, n of 0 to x of 0 equal the first value, 1. Then next, n of 1 to x of 1 equal the second value, 4. And last, n of 2 is 2 equal 7. This is how we can extract the values from that array or series. Okay, sometimes we have an array or series like this. X of n minus j 4, 7, 8, and 1. And in the question, we will put a row under number 8. That's for equation that we will face in digital signal processing later. What does it mean, this arrow? This is mean that your starting point will be from here. Your starting point will be from here. That will be x of and the number will be 8. Okay, that's for later on when we start with our calculation. That's it for today. Thank you so much. Have a nice day.